Have you ever wondered how your favorite online store knows exactly what you might want to buy next? Or how your map app finds the fastest route avoiding traffic you didn't even know was there? This is not magic. It is the work of smart people using artificial intelligence. These people build systems that learn from data. They create the helpful, intelligent features we use every day. An applied scientist is a person who uses science and data to solve these real-world problems. They are the architects of the smart solutions that make our lives easier and more efficient. This is the story of how their ideas become the helpful tools you use. We will explore the journey of an idea. It starts in a digital notebook, like a Jupyter notebook. It ends as a real working feature in an application. This journey is fascinating. It involves creativity, experimentation, careful engineering. We will look at the role of the applied scientist. We will see what they do each day. We will also meet their important partners, MLOps engineers. These engineers help bring the scientists' creations to life. They make sure the models work reliably for everyone, all the time. This process is like building a bridge from a brilliant design to a strong, sturdy structure that everyone can use. This journey is a team effort. The applied scientist has the initial vision. They understand the business problem deeply. They know how to use data to find a solution. They might build a prototype that proves an idea can work. But making it work for millions of users is a different challenge. That is where MLOps comes in. MLOps provides the tools and processes to make AI systems robust and scalable. Together, these two roles turn the promise of AI into reality. An applied scientist is a builder. They use the tools of machine learning and data science to create practical solutions. Their main goal is not just to do research, it is to solve a specific real-world problem for a business or a user. Think of them as detectives who use data as their clues. They start with a question. For example, how can we help customers find products they will love? How can we predict which packages will be delayed? They then dive deep into the available data. They look for patterns and insights that can help answer these important questions. Their work is very close to the final product. The focus of an applied scientist is always on impact. They want to see their work make a real difference. This means their models must be useful and effective. They spend a lot of time understanding the problem from a user's perspective. What would make this app more helpful? What information would make this decision easier? This customer-centric view guides their entire process. They are not just building technology for the sake of technology. They are building tools to help people. This practical application is what separates them from a pure research scientist. They bridge the gap between theoretical knowledge and tangible outcomes. Their responsibilities are diverse. One day, they might be cleaning a large dataset. They might be preparing a large dataset. The next, they could be training several different machine learning models to see which one performs best. They run many experiments. Each experiment teaches them something new about the data and the problem. They carefully measure the performance of their models. They need to be sure that the model is accurate. They need to be sure that the model is fair. They are constantly asking, is this model truly solving the problem I set out to fix? Experimenting, learning, improving. Ultimately, an applied scientist is a translator. They translate a business need into a technical problem that machine learning can solve. Then, they translate the solution back into a feature that a user can understand and benefit from. This requires strong communication skills. They must explain complex ideas to non-technical team members, like product managers. They must explain complex ideas to non-technical team members, like designers. They work in a team to bring a complete product to life. Their success is measured not by the complexity of their model, but by the value it creates for the end user. They are the creative force that finds new ways to use data for good. To succeed as an applied scientist, a person needs a strong foundation in several key areas. A strong foundation. The basics matter. First and foremost is a deep understanding of statistics and probability. These are the mathematical languages of data. They allow a scientist to understand uncertainty, measure the significance of their results, and build models that are statistically sound. Without a solid grasp of statistics, it is easy to be fooled by random patterns in data. This knowledge helps them design better experiments and draw more reliable conclusions from their work. It is the bedrock upon which all their other skills are built. Next comes expertise in machine learning algorithms. Know different types of models, simple linear regression, deep learning networks. They need to understand the strengths and weaknesses of each algorithm. This allows them to choose the right tool for the job. For example, a problem with image data might require a convolutional neural network, while a forecasting problem might be better solved with a time series model. Knowing how these algorithms work internally also helps them to debug and improve their models when they are not performing as expected. This is their technical toolbox. Of course, practical skills are just as important as theoretical knowledge. Proficiency in a programming language like Python is essential. Python has a rich ecosystem of libraries for data science and machine learning, such as Pandas, NumPy, and scikit-learn. An applied scientist uses these tools every day to manipulate data, build models, and run experiments. They must be comfortable writing clean, efficient code. Familiarity with cloud computing platforms, like Amazon Web Services or Google Cloud. These platforms provide the computing power needed to train large models on massive datasets. Finally, a great applied scientist needs strong problem-solving skills and communication skills. They must be able to take a vague business problem and break it down into a concrete, solvable machine learning task. This requires curiosity and a structured way of thinking. After they build a model, they need to communicate their findings clearly to a wide range of audiences. They must explain what the model does, how it works, and what its limitations are. This ability to tell a compelling story with data is what turns a good technical solution into a great product that everyone understands and trusts. Now, let's talk about MLOps. The ML stands for machine learning. The Ops stands for operations. Visual show continuous loop diagram. Data, train, test, deploy, monitor. MLOps is the process of taking a model from the scientist's computer, running it in a real-world application. It is the engineering discipline that makes AI scalable and reliable. If an applied scientist is the designer of a new car engine, MLOps engineers build the factory to manufacture that engine by the thousands. They make sure every engine is built to the same high standard and works perfectly in the final car. MLOps is what makes AI practical for businesses. Why does MLOps matter so much? A model that works on a scientist's laptop is just a prototype. It is not ready to handle requests from millions of users. MLOps provides the infrastructure for deployment, setting up the servers, setting up the software to run the model automatically. It ensures the model can respond quickly and handle a large volume of traffic. MLOps engineers build automated pipelines that can take a new model, test it thoroughly, deploy it into production with minimal human intervention. This automation is key to moving fast and keeping the system stable. Another critical part of MLOps is testing and monitoring. Before a new model goes live, it must be tested for more than just accuracy. Tested for speed, tested for security, tested for fairness. Once the model is deployed, MLOps engineers monitor its performance continuously. They watch for any signs of trouble. Is the model's accuracy dropping over time? Is it starting to make strange predictions? This monitoring is like the check engine light in your car. It alerts the team to a problem before it becomes serious so they can fix it quickly. This ensures the AI system remains trustworthy. Finally, MLOps is all about reproducibility and governance. It is important to be able to track every model that is in production. Keep a record of which data was used to train the model, what version of the code was used, and what its performance was. This makes it possible to reproduce a result, or roll back to a previous version if something goes wrong. It also helps businesses comply with regulations. MLOps brings engineering discipline to the creative process of machine learning, creating a robust and manageable system that can evolve and improve over time. Let's see how this works in the real world. Our first story is from an e-commerce company. Many customers would add items to their cart but never complete the purchase. The company wanted to find which customers would buy if given a small discount coupon. An applied scientist built a machine learning model. It used historical data, past purchases, browsing activity to predict purchase probability. It learned patterns of customers on the edge of buying. The result? A smart coupon system. The model was deployed with help from MLOps engineers. When a customer abandons a cart, the system decides whether to send a coupon. It targets only high-potential customers. This saved the company money by avoiding unnecessary discounts. Sales from abandoned carts increased by 15%. It helped the customer, who got a nice discount, and it helped the company, which increased its revenue. Our second story is from a logistics company. The problem? Fuel costs. Their delivery trucks drove millions of miles daily, and finding efficient routes was a huge challenge. The goal was to reduce total distance traveled. An applied scientist built a route optimization model. The model considered traffic patterns, delivery time windows, number of packages in each truck, likelihood of delays. It was a complex puzzle with thousands of variables, but the model found near-optimal solutions very quickly. The outcome? Reduced costs and carbon emissions. The MLOps team integrated the model into drivers' navigation systems. Each morning, the system calculated the best route for every truck. Drivers followed the optimized directions. Fuel consumption dropped by 10% in 6 months. That saved the company millions of dollars, and it had a positive impact on the environment. Deliveries became more predictable, and customers were happier. This shows how AI can make operations more efficient and sustainable. Our third story is in health tech. A hospital was struggling with long ER wait times. Nurses had difficulty quickly identifying who needed immediate attention. An applied scientist and team built a patient triage model. The model analyzed check-in information, symptoms, age, vital signs. It predicted a risk level for each patient, designed to assist, not replace, nurses' judgment. The result? Faster care for the most critical patients. MLOps tested and integrated the model into check-in tablets. At check-in, the tablet displayed a color-coded risk score to the triage nurse. Nurses made faster, more confident decisions. Average wait time for high-risk patients decreased by 25%. This is a powerful example of AI assisting experts in high-stakes decisions. It helped hospital staff save lives by getting critical care to those who needed it most, faster.